completely off on your calculations?
Yeah. Yeah, Alex is. I know you. This morning I saw that you sent me an image.
Yes.
Right. Which problem is that, Alex?
Sorry, I don't have it out anymore. But I think with these examples this morning, it clarified a few things.
Okay. Is that a homework question?
Yeah, it was.
Yeah. So that's why I did mention that I've not finished teaching the other possibility, right?
Yeah.
So you're trying to figure out. I'm glad that you're trying to figure that out. Okay. That's why in the quiz, I did not ask you question based on that sort of construction, right? It would not be fair, right?
Yeah.
Okay. Right. So the next topic, okay. Now the next topic is I won't call it the most difficult. Okay, I think you all been through the most difficult already. I think the most difficult topic was in term test 2. So the topic that I say is the most difficult in term test 2 is question number 1. Okay, where we combine thick wall and thin wall analysis, and we combine wide flange and box beam. Okay, so this is one of the most toughest question, but surprisingly in the term test, right, this is question number 1. A lot of people do well for question number 1, a lot. Okay, the average was about 6.5. Okay, where things go wrong is question number 2. Okay, so question number 2, what is so tricky about question number 2 is it combines sandwich material with unsymmetrical loading. Okay, so I can understand that you all spend a lot of time on question number 1. Question number 2, a lot of you got the right steps, but I think it's time. Okay, that's where you're, and I can understand that. Okay, where there's time, you'll make mistake. I was given to do questions by Tesla recently. Okay, so Tesla hunted me down. I think it's on the YouTube videos that we have done. And they asked me to do 6 questions on structure analysis in 3 hours. And I did them in less than 3 hours, but I can understand the stress that you're going through. Okay. The last time I took an exam was like 20 years ago. When I was asked to do those questions, I was like in an exam also. Okay. But I was not given time to do corrections. Okay. So when I have time, I'll tell you guys that story more. Right. So we are going to look at combined loading. Okay, combined loading analysis. And principal stress. Okay, now this is real engineering now, okay? And when this term comes in analysis, okay, is where the topic is not so straightforward because you are required to do analysis, okay? So why this topic is difficult, we are going to integrate we're going to integrate knowledge from week 1 to week 10, okay, into structure analysis. So what do I mean by that? We are going to combine, what have we learned? Axial loading, right? That was week 1 to week 2, yes or no? Then we are going to combine shear forces or shear stresses. That is week 3 to week 5, right? Week 3 to week 5. There's a reading week in between. I'm aware of that. Then we are going to combine normal stress due to bending moment. So that is your week 07 to week to week 8. And finally, to select the right material, we have to apply principal stress using Mohs circle. So this is with topic of week 10 to part of week 11. Okay, so that is why, again, this topic is not difficult. It is the analysis and the integration of all this topic, okay, to be now able to specify, okay, realistically what material you can use. Okay, what material you can use. That's where, if there's any value of this course, this is this. Okay, this is real engineering work now. Okay, we were teaching before, it's just silos. I was teaching you all the foundation. Now we're going to like integrate everything together. Okay, and now when you calculate the stress value, okay, you will have the confidence to say that this is correct. Okay, this is real. Okay, not Mickey Mouse stuff anymore. Okay, so let me highlight to you the complexity first. Okay, then how to simplify the complexity. Okay, right. So if we look at, I'll show you what is the confusing part. Okay, then with this confusion going on, okay, how to design. Okay, because it can be, now I write all this, I'm pretty sure that some of you are overwhelmed. I agree with that. Okay, it can be overwhelming. I totally agree. Right. So if we were to look at normal stresses, yeah, if we were to look at normal stresses induced by axial forces and bending moment. Sounds like trouble, Patrick. I'll say something about Patrick. All of you meet traffic, okay? Meet Patrick. Patrick has passed this course already. Okay, he did well. And I'm not gonna embarrass him, but I'm gonna ask him this question. Okay, Patrick, what are you doing here again? Okay, Patrick is taking this. He already passed. Okay, and he's taking this course again. Patrick, can you speak on a mic or no?
Hello.
Yeah. So
Hello.
Patrick, hello Patrick. Why are you taking this course again? Am I right or I'm wrong?
From my mark, from what I saw, it wasn't that great.
It's not bad, Patrick. You cheeky sort. Okay, you already passed. Okay, but why are you taking it again, Patrick?
So like if I want to like apply to a job and all that, and they see my mark uh in my transcript, I feel like this strength of material is it kind of feel like it doesn't feel great to have a bad mark. So that's why I'm taking it again to improve my mark. And also it's pretty good because if I ever want to do the PEO exam, or I want to review this again, I'm taking it again just to remind me how to do the analysis or all the calculations and all that.
Okay, thank you, Patrick. Patrick, mark is not bad, okay? I think what is only fair to say is, I think McMaster should put your grades and what's the class average, okay? And the class average was, in general for this class, is about a C minus, okay? Patrick's grades is not bad. He's above the C minus, okay? So that's where there's no point saying the grades, just your grade. It has to be a class average, okay? A lot of times, I know for the fact some courses are known as bird course. Everyone gets A, and if you get A, yeah, the value is not there at all. But anyway, thank you, Patrick. Okay, I don't mean to embarrass you, but I know you already passed. I'm always curious, is this your younger brother or is it you? But it's you, now I'm sure, okay? Now, coming
I'm
back.
almost done too.
Yeah, I know that, okay? So coming back to here, normal stresses induced by axial forces and bending moment. Okay. So if I were to combine both of them, okay, we know, so this is the formula. This is the general formula. Okay, don't worry about the sign, positive or negative. Just the positive or negative bending moment is all on the moment vector. We know that. Okay. So now we know that the normal stress is equal to force divided by area, right? Then we know that there's possible of two. So we are going to calculate stress in x, okay? So the load is in x direction, divided by area. Then we know that we have my over Iyy multiplied by z. And then we know that we can have another moment in z divided by Izz multiplied by y. Okay. So if we look at the stress field, remember what we are calculating down here. So this is due to the axial force. And these two are due to bending moment. Okay. So if we were to look at how the stress field will be distributed, okay, this is just a sketch. So on this line, right, is our normal stress in the x direction. On this line over here, it can be your y or your z, depending on what you're plotting. And we know that the stress distribution will look this way. Okay, this is just an example. So if this is our 0, okay, you realize that there's an offset. Okay, so what do I mean by offset? So over here, this is our, over here, this is our geometric centroid. Oh, by the way, this course, all the notes will be available to your gadget from McMaster. I'm not going to turn off the avenue to learn at all for this course. Okay, so you can anytime, if you have to record something, you can come in and access it. And the YouTube videos, okay, I'm not going to delete them at all. Okay, you use them whenever you want. I'm not bothered at all. If